All right, guys, for this second video, we're going to move on to the second different limacon curve, which is called a cardioid, but more often than not in class I would usually call it's just the heart shape. All right, okay, we're going to look at this one, and this is one where the A and the B value are basically going to be the same value. Okay, the ratio of A and B is 1. So you always identify A and B first, and that tells you which of these four curves you're going to get. All right. Now remember, all of these examples, these are all of these ones. Actually, I just do this. Okay. So remember, with cosine, you can see all of these graphs, these examples, they're all symmetric to the x-axis. And, you know, the inner loop, which we did on the last one, is on the x-axis. It kind of comes in here on the x-axis right there. All of these are symmetric to the x-axis. All right. The next one, where we'll do it in the next video, where it has a little dimple, that's on the x-axis. If we were just to change it to sine, then all these key points, the dimple, the inner loop, are going to be on the y-axis if it's sine. All right. So this is one that we're going to do, and it's actually just the next one, number 2, on the next page. So let's go to number 2. All right, so number 2, you see we have r equals 2 plus 2 cosine of theta. Let's make this a little bit bigger so we can see, fit everything on here. All right, so you can see the A and the B. Remember, the A really represents the vertical shift, you know, if we were to graph a cosine wave, and then the B kind of becomes the amplitude when we graph cosine waves. So if A and B are the same, their ratio is just 1. This is where we're going to get the heart-shaped graph, you know, also known as the cardioid. All right, so that's the main thing. And since it's cosine, it's going to be a sideways heart. All right, it's going to be a horizontal heart that's symmetric to the x-axis. So now let's just apply everything we know about max-min equilibrium. All right, so this, the A value, that's the vertical shift, so that's the equilibrium. So the equilibrium's 2. The max, since the amplitude here is 2, we just add 2, so we get 4. The minimum, we just subtract 2 from the equilibrium, we get 0. So these are the only values that we're going to get for, well, normally it would have been the y. In this case, it's r in the polar coordinate system. Again, good thing about these limacons, you always just have theta. So the period is always for these 2 pi. Increments is 2 pi over 4, which is pi over 2. So the 5 values that we're going to plug in for theta are just the intercepts in the unit circle, which are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. All right. And then cosine always starts at the max, unless there's a negative in front of the amplitude, and there's not. It's a plus, so it's going to start at the max. So we're going to have 4, and it's going to go down to the equilibrium, go down to the minimum, come back up to the equilibrium, and end at the max. And that's pretty much it. So then let's graph those, and then we know we should get a sideways heart when we graph this. All right, so 0, 4, let's look at this. 0, 4. 0, 4, remember, go to the angle first. All right, 0, 4, a lot of students, what they would want to do is they would want to put 0, 4, 1, 2, 3. They would want to put it here. But that's the rectangular coordinate system. 0, 4 is I go to the angle, and then it's the fourth circle here. 2, 3, 4. That's going to be the first point. So 1, 2, 3, 4. It's right here. Okay, pi over 2, 2. So here's pi over 2. The radius is positive, so we go to the second circle. Good with that. Then pi 0. So whenever that radius is 0, it's at the it's just at the origin. 3 pi over 2, 2. Right, it's right here. Radius is positive 2, so it's going to stay at the second circle. And then 2 pi 4 is really the same thing as it's this same point again. All right. Now remember, we knew going in, big picture, it's going to be a sideways heart. You can see the point where we got the equilibrium, or this middle point. This is where it's going to, we're going to connect it, and it comes a little bit above here, and then this is the heart shape, comes down here, and then it goes up. When we get this little part right here, you don't have to plug points in there. You just have to know the general shape. So, all right, this is probably going to be bad, but we're going to try. All right, it's going to go up. Again, how far it goes up, I'm not going to be picky with that. All right, it comes up. I'm going to try to draw it so it's symmetric to the x-axis. And there's my sad looking heart right there. Hopefully your heart looks a lot better than mine. Other thing I'll just say, if I were to just take this cosine and I were to change it to sine, then it would be a vertical looking heart, which is still pretty bad. If I were to take this plus and I were to change it to a minus, it would flip over the y-axis. So then like this point would flip over here. Oops. Hold on. This point would flip over here. And then this part of the circle would flip this way. All right. But biggest thing is when you look at these ones that have a vertical shift, get the A and the B value, and then figure out the ratio of A over B. If they're the same like they are in this case, you get the heart-shaped curve.